Welcome to this lab. In this lab, we will look at BigQuery machine learning using Soccer data. So it will be very exciting since we're going to learn a new thing called machine learning. So first of all, you have to open the BigQuery. If you can't see it from here, you can type in BigQuery from this text box here and select it. Okay, so I already opened. So in this lab, we will continue to use this Soccer database and the tables inside. The task 1 we have finished. Now we move on to the task 2, calculate the shot distance and the shot angle. So in this session, we will create some user-defined function in the BigQuery. Previously, in the previous lesson, we actually didn't create function. We will just call it out from the select statement here. Now we are going to create a function. So this function will calculate shot distance from x and y coordinate. To motivate the need for the function, start by looking at the position field in the events table a little bit more. This is a repeater field that contains one or more XY pair per event. I can show you how it looks like. You can just go to type in circle.events. Yep, this is the position X and Y. And so you can even look at the structure of the table. So the position is actually a data type of a call record. So the first X and Y pair in position for events that are shot represent the location on the field from which the shots originated. Just to take notes, right? Calculating the distance of a shot from a given location to the goal involves using the midpoint of the goal mouth, which is 150, as the ending location, the non-average dimension of the soccer field. There is no standard field size. Okay, good. So I create I open a new window and then I put in this. So this is the first function. So get the shot distance to go. Okay, this is what we mentioned here. The 150 is the goal mouth. Okay, so you minus the x and y input parameter when people assign the values here. Okay, so if you not run, you can create run, and this will create a new function. So the new function already exists, already created that. So it will take two integer as the input, and the output type will be a float. Then the actual logic implementing the two-dimensional distance formula on the scale x and y coordinate distance. Okay, so that is done. So we are going to calculate shot angle from x and y. The general process here is similar to the shot distance calculation, but apply to a shot angle. In this case, the angle calculated is the one made by the locations of the shot and the goal line. Right, the larger angle are arise from being close to the goal and in the center, so it is somewhat correlated with the distance calculation performance above. Right, so the shot angle calculation involve using BigQuery trigonometric functions. Let's create another new window. So I will run this first. So this create a shot angle function like the shot distance function above with two integer input and a floating point output. Two integer input, and this will return the output as a float. Yep, I have created the function. Now move to the task 3. Task 3 is create expected goals model using BigQuery ML. So this is the one that is getting exciting. So in this session, you will use BigQuery ML to create and execute machine learning model in BigQuery using the standard SQL query. So if you are good in SQL query, this will help you a lot to create a simple BigQuery model, a machine learning model. So in this case, you will create an expected goals model on the soccer event data to predict the likelihood of a shot going in for a goal given its type, distance, and angle. These are known to be a good predictions of the chance of a goal. Expected goal model are commonly used in soccer analytics to measure the quality of the shots and finishing savings ability given shot quality. So and they have a variety of application in both retrospective match analysis and making projections. I also have put in some of the benefit of why you need to create the model. So to estimate the shot quality and more objective performance evaluation to identify trends and efficiency and to train the predictive system. So the benefit explanation is in summary here. So you can take a look. So the most interesting part is you can inform coaching decision on shot selection, build up play, etc. Given, say for example, I try to explain this part is not all the shots are equal. Given there are two different players, they are standing in the same angle and they try to do a goal shot, but not all the players will achieve it successfully. So in this way, right, you will not only this will help in doing the build up play, and this allowed the coach to identify which player need more practice. Okay, so this is how you create the model inside the BigQuery. So the model name is this one, SG Logistic Regression Model. So I run this first. So the model type we use is the logistic regression. And the input labels is column as is goal. You're getting that from the events table joined with matches. So this looks familiar because in the previous lab, right, we also have done that. It's just that we were not doing it in the machine learning model. This will take some time. Okay, the model has finished. There's a button here, go to model. You can click that. So this will open a new tab and take a look at some of the metrics, particularly in the log loss and the ROC AUC. Yeah, you can go to the evaluation here and take a look. So what is a log loss? A measure for model performance between 0, perfect, and 1. The greater the log loss, the greater the predicted probability diverge from the actual label. So that means the lower the better. Okay, so ROC AUC is 0.7. So area under is severe operating characteristic curve. So these are some of the findings I have. So in binary classification problem like SG logistic regression model, the log loss and ROC AUC are two critical metrics under aggregate metrics for evaluating model quality. Here is why that matter. Okay, so there are two metrics. One is the log loss and the other one is the ROC AUC. So we first look at the log loss. So the goal here is accurate probability and the ideal value is near 0. Okay, and then for the other one, the metric is ROC AUC. The goal is for accurate ranking. So it's close to 1, the better. So the summary here, use log loss when you care about probability calibration, which is important in XG model. You are using the model output directly in decision making. Use the ROC AUC when you want to evaluate ranking separation power, you're comparing models or tuning threshold. Let's query the model. Yeah. So you can also look at the model which is created over here. Okay, so I query this model now and I get this result come out, and there are the process input we have is shot type, and the category weight is penalty. Category weight dot category is penalty, free kick, shot, and the shot. So normally the penalty kick will have a higher chance of getting a goal shot, and followed by a free kick shot and also the shot. And to explain the difference here, okay, the logistic regression assigns the weight to each input feature. This weight indicates how each feature affects the probability of the outcome. Positive weight increase the likelihood of a goal. If negative weight is decrease the likelihood of a goal. Higher absolute value create impact on the prediction. So just now we already look at the shot penalty normally will increase the chance of getting a goal shot. Okay. So the shot distance also is another factor. Every extra unit of the distance from a goal reduce the goal probability. Okay, the shot angle wider, more open angles slightly increase the goal probability. Right? If you hit a shot from the corner of the goal mouth, right, it's so hard. So you have to be like in the middle of the field. So if you hit the ball, you get the goal. The chance of getting it into a goal is highly increased. Let me run this new model. So this is to create a boosted tree model for expected goal. Now you will fit the boosted tree model to the data using the BigQuery ML implementation of XGBoost and compare the result to the previously fit logistic regression model. In theory, boosted tree can be more accurate because of their ability to take into account nonlinear relationship between features and the outcome as well as interaction amongst features. So the SQL statement is identical to the one that you just seen, except there's a change in the model type to pick a boosted tree classifier and the name of the model object created. This will take several hours or to complete, so please be patient. Okay, it takes around 20 minutes to finish this creation of the model. So yep, let's go to the model now. Okay, you can go to look at the evaluation. The log loss and the ROC AUC of the boosted tree model is pretty similar to that from the logistic regression model, but slightly worse. Higher log loss and lower ROC AUC. So in this section, BigQuery was used to fit machine learning model using the soccer data, and expected goal model can be created in the variety of way. Now move on to the task 4. Apply the expected goal model to new data. So I run this query to query against this the previous model that we created. So this called the ML predict function on the logistic regression model that was fit previously. The select statement create the same field on all shots from the events data as the one used to fit the model, but this time it filter to only World Cup matches instead of leaving them out, since those that are the shots that the model is to be applied to. Okay, so the output shows a couple of prediction related fields along with the original fields in the data of shot type, distance, angle, and the success. Okay, predicted is goal. Is binary prediction of whether the shot will result in a goal or not. Predicted is goal probability, like this one. An array pairs that shows probability of each shot being successful and not from the model. So identify most unlikely goals using the model probability. Let's do this. Yeah, this one come with player name. So building the on the previous section, that yielding probability for all shots in the 2018 World Cup, use BigQuery to extract the probability of each goal, then sort them from lowest to highest to see the most unlikely goal score in the World Cup based on the factor in the model. Theoretically, this should use a list of some of the most impressive goals in the tournament, at least based on the factor in the model, distance, angle, etc. This build the ML predict function called in the previous section, filtering to only shots that will go excluding penalty, since the goal is to get the most impressive goal, extracting only the probability of goal being scored from predictions and ordering by that. A few fields are added in the select statement from the events data and the other tables that can be joined to it to get other informations of interest on each goal, like the player and teams who score it. It match date and information and the minute into the match of the goal. So it's ordered by the predicted goal probability. So the top few lines shows the 2018 World Cup goals that the model believes had at least slightly chance of going in. All the fairly long short distance, nearly 30 meters, and relatively tight angles between 10 to 15. So this is the predicted goal probability. So this is a shot, and that from the distance of and also the angle. Okay, so if I sort by descending order, just want to take a look. So the number increase. So you can see the short distance is lower and the short angle is actually wider. This increased the chance of getting a goal. Thanks for watching.